Let me ask you something. Have you ever been spending time with friends and the topic of percentage yield comes up and they're having a lively discussion, but you don't know what they're talking about? And you don't want to seem like you don't know what they're talking about, so you try to interject some comment? What do you think the percentage yield for that reaction would be? Uh, I think there should be a constitutional amendment banning percentage yield. Be honest. Has this happened to you? I've been there. And don't worry, I can help. Percentage yield is actually not a complicated idea. It's simply a way to express how much of some product has been produced in a reaction in an experiment compared to how much we predict would be produced using stoichiometry. We can express this as an equation. Percentage yield is equal to the actual yield divided by the theoretical yield, both of those being measured in grams, in mass anyway, multiplied by 100 at the end to make this into a percent. Now the actual yield would be the amount that you measure in your experiment. You put it on your scale, you figure out the mass in grams. The theoretical yield would be what we predict using stoichiometry, which we've already been working with. So these two put into a ratio and multiplied by 100 give us the percentage yield. Now let's try some. In this first example, we're given both the theoretical and the actual yield of hydrogen gas in a reaction. This is a very simple problem. All we have to do is divide those two. So our percent yield is equal to our actual yield, which in this case is 22.0 grams of hydrogen gas, divided by our expected or our theoretical yield, which was 30.0 grams of H2, times 100 to make it a percent. And on this problem, our percent yield is going to be 73.3%. In this problem, we have a bit more work to do because they don't give us the theoretical yield. We have to calculate that and then use that to calculate percent yield. We're given that 36 grams of water are decomposed. From that information, we can predict how much hydrogen gas should form ideally. Before we can do that, though, we'll have to write out an equation for this reaction. We have water initially, which is decomposed into hydrogen gas and oxygen gas. And then we need to balance that equation. We know that we start with 36.0 grams of H2O. And from there we want to figure out how many grams of H2 should be produced. So we set this up as a dimensional analysis problem, beginning with what we know, 36.0 grams of water. We need to get rid of the grams of water and convert that next to moles. And there's 1 mole of water to every 18.0148 grams. That's the molar mass of water from the periodic table of elements. Our grams of H2O cancel. Now we need to convert that from moles of H2O to moles of H2, the substance we're asked about. From the balanced equation up top, I can see that for every 2 moles of water we have, we end up with 2 moles of H2. And lastly, we need to convert from moles of H2 to grams of H2. And the molar mass for 2 hydrogens would be 2.0158 grams. Moles of H2O cancel with moles of H2O, moles of H2 cancel with moles of H2. For units, we're left with grams of H2. And when we plug this into the calculator to solve for the grams of H2, we get an answer of 4.028 grams. That is our theoretical yield. So from here we can use that information as well as the 3.2 grams that was given to us as our actual yield to calculate percent yield. So percent yield here will be our actual yield, 3.2 grams, divided by our theoretical or our expected yield of 4.028 grams times 100, which gives us an answer of 79%. There now, that wasn't so bad. You can go out and impress your friends with your newfound knowledge. Man, what do you think the percent yield on that reaction was? Probably 79%, dog. Yeah, playa.